to Wonders of the Universe, where in this episode we explore the red planet, Mars. The red planet has preoccupied us for more than a century. Fantasy writers and scientists alike have always speculated about the possibility of life on this world. Even today, we hope to find its microbial traces. Mars has some of the most dramatic terrain in the solar system, including 4 colossal volcanoes. The greatest of them, suitably christened Olympus Mons, covers an area equivalent to Arizona and is capped by a crater that could swallow the entire island of Hawaii. Another prominent feature, Valles Marineris, is a tangled network of wide, deep canyons wrapping its way around half the planet. These landscapes are on such a grand scale they can properly be appreciated only from space. The largest Martian feature is, at first glance, the least obvious. The major volcanoes, the Marineris trenches, and large areas of rifts and fractures are associated with the Tharys Bulge, a vast region where the planet's sphere was pushed out of shape by the internal pressure of molten rock beneath the crust. The volcanoes were fed by this great blister's hot interior. The magma's journey towards these volcanoes may have formed an underground channel whose crustal roof eventually fell in to create Marineris. Scans taken from orbit reveal the presence on Mars of ancient riverbeds and sedimentary soils. Scientists still hope to find some microbial life underground, or at the very least, fossil traces from long-dead creatures. Mars did once have a much denser and warmer atmosphere than today, along with plenty of liquid water. Unfortunately, over billions of years, much of the atmosphere has escaped into space because of the planet's weak gravitational field, leaving a dry and frozen world soaked in harmful ultraviolet radiation from the sun. The volcanoes, too, are no longer thundering. The largest canyon in the solar system cuts a wide swath across the face of Mars, named Valles Marineris. The system of rifts, channels and gullies is more than 3,000 kilometers or 1,860 miles long and up to 10 kilometers, 6 miles deep. By comparison, the Earth's Grand Canyon in Arizona is the merest scratch. The origins of this dramatic scar are uncertain. The Martian crust may have cracked billions of years ago as the planet cooled. At some time in Mars's past, powerful flows of water carved many deep channels, such as these sinuous examples at Nanadea Vallis. The young planet must have had a thicker atmosphere and warmer climate than it does today. This crater near the Martian North Pole, situated in the Vastitas Borealis plain, is 35 kilometers, 22 miles in diameter. A huge lake of water ice is clearly visible, stranded in magnificent isolation after the waters that originally fed into the crater retreated. Olympus Mons is the largest volcano in the solar system. Although it is 3 times taller than the Earth's highest peak, Mount Everest, Olympus Mons would not be difficult to climb, because its slopes ascend very gradually over an area wider than the entire Hawaiian volcano chain. The low gravity of Mars, combined with a relatively static surface crust, allowed the volcano to build up over time during multiple eruptions. A more detailed view of Olympus Mons shows overlapping vents or calderas, resulting from a series of eruptions. The smaller calderas are the youngest. Obviously, the volcano diminished in explosive power over time. It was unlikely to blow up again. The southern polar ice cap, seen here during the Martian summer months, is made from a mix of carbon dioxide and water ices. In winter, the ice cap doubles the extent of its surface coverage. The northern ice cap consists of water ice overlaid with a thin frost of carbon dioxide. This perspective view shows distinctive step terraces. Similar features are found at both of the Martian poles. The terraces may have formed as a result of wind erosion. Polar ice pushing forwards and retreating with the changing seasons leaves its mark on the underlying terrain. Closer scans of layers at Chasma Boreale, a deep canyon near the North Pole, shows ice-rich tiers deposited between the darker beds of dust. As with so many Martian features, the exact mechanisms that created these landscapes are not yet fully understood. This view of the so-called Schiaparelli hemisphere of Mars is named in honour of the Italian astronomer who, in the late 19th century, thought he could see what he called canali on Mars. He just meant channels, but his work was interpreted by other astronomers to mean canals, artificial water systems built by intelligent beings. Today we know that varying patches of light and dark terrain on Mars, seen through low-powered telescopes on Earth, created misleading illusions. The following series of images, again I've had to break down, which ruins some of their spectacular presence, are of the fine red soil peppered with countless volcanic rocks, typifying the Martian terrain, especially in the flat plains favoured as safe targets for robot landers. The redness in the red planet is a product of its thin topsoil, which contains rust-coloured iron oxides. Several landers are sitting on the Martian surface, well preserved in the cold, arid conditions. A heat shield discarded by Mars rover Opportunity is visible at the top left, and at right we see the crater gouged out when the shield first hit the ground. Opportunity's twin, the Spirit rover, landed in Gusev crater, a region thought to have held a lake at some time in Mars's past. These rocks look as if they were made by sediments deposited by water, but initial visual clues can be misleading. These were more likely volcanic in origin. A more subtle clue is in the sky, where a constant gentle pink glow reveals the presence of fine dust in the Martian atmosphere. That dust may contain clay minerals. Clays are made by slow erosion of rocks by water. This rock may be resting on the Martian's surface, but it is not part of the planet's native material. It is nickel-iron meteorite, here being examined up close by NASA's Opportunity rover in September 2010. Space probes have occasionally arrived at Mars, only to find global dust storms obscuring all the surface features they are attempting to study. When a storm is raging, only the peaks of the tall volcanoes can be seen from space. As the dust retreats, the rich details of the surface are slowly revealed. The orbit of Mars around the Sun is not quite circular. Its distance from the primary source of warmth varies according to the seasons, and these shifts affect its weather. Global dust storms tend to occur during perihelion, the period of closest approach to the Sun. This central region of the Valles Marineris system, known as Ophir Chasma, is a chaotic landscape of trenches and plateaus. Narrow channels have collapsed into the deeper valleys below. These falls may have been triggered by ancient flooding and mudslides from sudden releases of meltwater. Relatively young craters pepper the landscape of Mars. This strange chain of craters at Phlegethon Catena has not yet been fully explained. They may be the results of subsidence rather than impact. Some equally strange-looking rivolute shapes on the flanks of the Pavilions, Mons Volcano, are probably the scars of lava flows. The floor of the 100-kilometer diameter, 62-mile Nicholson crater is raised in the middle. This is a common feature of impact craters, created as the distorted crust settles back after the initial shock and heat of the smash. Grooves and channels indicate that some kind of erosion process have worn away at the dome-like central structure. An overhead view of the Kasai Vallis and Saqqara Foyce regions show chaotic disruption, possibly caused by brief and extremely violent flooding. The perspective rendering of radar data shows that the sides of the large crater in that region appear to have been eroded by wind and water. In its liquid guise, that water has long since vanished, but this shot of Promethei Planum shows a layer of water ice as deep as your Mediterranean Sea. This outflow channel at Mangala Vallis must have been cut by large quantities of water. Scientists are trying to work out if those great volumes surged just briefly in the past, or worked more slowly over longer time spans. These sinuous gullies on the flanks of a southern crater are suggestive of very recent water activity. Did liquid water exist for long enough to encourage the possible emergence of life? Or are these gullies just the product of wind and dry dust? This false colour image, based on data from the Mars Global Surveyor spacecraft, plots the distribution of various mineral types, including clays. At Morth Vallis, an outflow channel in the Northern Highlands, iron and magnesium-rich silicate minerals are shown in red. The aluminium-rich silicates in blue, with other silica-based compounds in yellow and green. Hundreds of layers of similar thickness, texture and pattern have been exposed by erosion in a 64-kilometer or 40-mile wide impact crater in western Arabia Terra. The layers are a record of repeated episteric changes that took place at some time far in the Martian past, as layers of sediment were deposited one on top of the other, time and time again. They may have been formed by dust settling out of the atmosphere, or perhaps by waterborne erosion products. This Mars Reconnaissance Orbiter close-up of a crater in the Martian southern hemisphere reveals a variety of features, including the sharp shadow on the right, cast by a dust dune, outcrops of bright rock near the bottom, and the dark streaks along the left side left by Martian dust devils scouring the surface. The bright layered rock in this detail of Holden crater is thought to have been deposited by a powerful flood that broke through the crater's rim. Part of the floor of a large impact crater in the southern highlands, north of the giant Hellas impact basin. The fractures appear dark, probably as a result of wind-blown sand trapped in the cracks. The detail of Cerberus fossae, a long system of faults in the crust. Cerberus fossae was the source of a large volcanic eruption that draped an adjacent region, Athabasca Vallis, in lava. The ripples in the middle of the deep channel are patterns of fine dust shaped by the wind. I personally love these next few images. Opportunity and its sister robot Spirit have been on Mars since early 2004. Here, Opportunity looks into Endurance crater and sees its own shadow. Two wheels are visible on the lower left and right, while the floor and walls of the unusual crater are visible in the background. As each rover descends from the safe haven of its carrier craft, it looks back and photographs the system of airbags and folding panels that delivered it onto the Martian surface. The Spirit rover uses a camera on a mast to scan itself from above. In this mosaic of close-up images, the rover is powered by solar panels. On some days, dust collects on the top of the panels, reducing their efficiency. Most of it eventually blows away again. The Mars Reconnaissance Orbiter took this image of Phobos in March 2008. From a distance of 6,800 kilometers, 4,200 miles, the most prominent feature is a large crater called Stickney. At the lower right, a series of troughs and crater change is obvious on the parts of the Moon. They may have formed when material ejected from impacts on Mars later collided with Phobos. A detail of Stickney crater, in which was named for Chloe Angeline Stickney, mathematician and wife of astronomer Asaph Hall, the man who discovered Phobos and Deimos in 1877. These blocks appear to be ice floating on a recently frozen sea, all of which is now covered by fine orange-red dust. The unusual plates were photographed by the European Space Agency's Mars Express spacecraft. Oddly, this region lies near the Martian equator and not near either of Mars's frozen polar caps, where major ice formations might be expected. Without the covering of dust, any water or ice in the equatorial regions would quickly evaporate. These plates are very similar in appearance to ice blocks in the seas around Antarctica. At 730 metres, or 2,400 feet wide, Victoria crater is a relatively insignificant feature in the landscape of Meridiana Planum, region close to the Martian equator. However, it is one of the most intensely studied regions of the red planet's surface, thanks to its location close to the landing site of the NASA's Opportunity Mars rover. Created this unusual textured rock on Mars, most probably a volcano. Dubbed Bumpy Boulder, the strange stone was found by the robotic Spirit rover. Pits on the ragged surface may have formed from gas bubbling out of hot rock ejected by a Martian volcano. Several similar rocks are visible nearby. Although the atmosphere on Mars is extremely thin, a suspension of very fine dust particles diffuses the sunlight, especially when the sun is low on the horizon. This mosaic image was taken by the Mars Pathfinder lander at Ares Vallis during July 1997. Sojourner, the first wheeled rover to explore the surface of Mars, moves away from the landing ramp of the Pathfinder delivery vehicle in July 1997. Part of the airbag landing system can be seen at the lower right. Sojourner pushes up against a rock named Yogi and makes contact using an X-ray spectrometer instrument. Yogi turned out to be very like common volcanic basalt found on Earth. Nereus crater is a small impact feature on Mars with a diameter of about 10 meters or 33 feet. It's located just south of the planet's equator in the otherwise relatively smooth Meridiana Planum region. It was discovered by the Opportunity rover in September 2009. This impressive feature at Meridiana Planum, here viewed by the Mars Reconnaissance Orbiter, is approximately 800 meters, half a mile in diameter. It has a distinctive scalloped shape to its rim, caused by erosion and downhill movements of loose material in its walls. Layered sedimentary rocks are exposed along the inner walls. The rippled features in the middle are products of wind-sculpted dust. Although liquids freeze and evaporate quickly into the thin atmosphere of Mars, persistent winds can cause large sand dunes to flow and even drip as if they were liquid. The dark arc-shaped droplets of fine sand are called barchans and are the interplanetary cousins of similar Earth-based sand forms. Barchans can move intact downwind and can even appear to pass through each other. Mars has two small moons, Phobos, shown here, and Deimos. They're only a few tens of kilometers in diameter, and their irregular shapes suggest they must have been stray asteroids captured by the Martian gravitational field. The grooves on Phobos have not yet been explained. Phobos, the largest and innermost of two Martian moons, is the darkest moon in the entire solar system. Its unusual orbit and colour indicate that it may be a captured asteroid composed of a mixture of ice and dark rock. Phobos seems to be covered by a thick layer of loose dust. The tiny moon's orbit around Mars is continually decaying. It will likely break up and crash into Mars within the next 50 million years. And that concludes our look at our most explored neighbour, Mars. If you found this interesting at all, do please hit the like button and subscribe to the channel. And if you hit the notification bell, you'll be alerted when every new video uploads. Thank you very much for watching, I really appreciate it. Do take care everybody. Peace.